In this video, we are going to talk about projects because many people ask me like how to come up with ideas for projects. They would like to improve, they would like to learn something new, they just don't have ideas. And Chris, he has this YouTube channel with many different projects. So I would like to talk with Chris about this topic, and especially how do you come up with ideas, Chris?
Sure, yeah. So mostly my ideas come from watching other YouTubers and seeing what they're doing. And it's kind of like, maybe I could recreate that and produce something just as good or maybe even better. So I try and look around and see what people are doing, and then you just play around and hopefully something good comes out of it.
I think this is like very good idea because, or this is at least first point how some people can start. Or do you have any other ideas? Sometimes I know complicated projects come up with simple ideas. I remember my daughter telling me, I would like to have like a wizard wand with LED, and I'm like, yeah,
Yeah,
LED, but maybe we could put there like motion sensor and recognize movement. And I was,
exactly. Yeah. And sometimes things fall out of experiments. So I used to be playing around a lot with audio on the ESP32. So I was trying out different microphones, different speakers. And then eventually that kind of triggered some ideas around kind of, it's a Wi-Fi enabled device. Why not build a walkie-talkie? All the
Mhm.
components are there. It's just modules you plug into a board. So this was one of my quite early projects. And I ended up making a PCB just because I couldn't deal with all the wires on the breadboard going everywhere. It was just impossible to manage. And I was just learning about PCBs, and I thought, well, I can just build a PCB with pin headers and then plug the modules into it. And that avoids all of these wires, which keep sort of either not connecting properly or falling off. And I just couldn't follow my schematics at all on breadboard. So that got me going into PCBs.
Oh, I didn't know this. So I think this is a very good example when people are worried a little bit like I can't do it or something. It's not very difficult. So did you follow some tutorials, or how did you design your like kind of first PCB? Or
Sure, yeah. So how did I find, yeah, that's a good question. I'm trying to remember what even drove me to making a PCB. I think I must have seen some YouTubers using services like JLC PCB and EasyEDA. And I've never made a PCB before in my life. So although I did a degree in electronics, we didn't do any sort of electronics really. Most of our stuff was a bit of soldering, and then it was all quite high level kind of electronic systems. So I think I must have seen some YouTubers using some things like EasyEDA, which seemed like an easy online tool to use. And I think I must have just jumped in and tried to do something. And with my vague memories from my degree, I think I had enough knowledge to and enough kind of looking around at other people's projects and modules and Arduinos to know enough to be dangerous in some PCB design software. So it was kind of like, oh, all the headers are 2.54 millimeters, so that's probably a standard thing. I'll just stick some of those in. I need 5 pins, and there's VCC and ground. So I think it was just jumping in and trying it and
Mhm.
hoping for the best.
Okay, so now I have two questions. So when did you start designing PCBs?
When did I start?
Yeah,
So I
2 years ago, three, five. You already mentioned
probably,
it.
yeah. So if you look at, I mean, this is one of my very early projects. So four
four
years ago,
years.
yeah. So 4 years, I would have started doing some more serious ones. So these are probably, yeah, these would be the first ones I did would be these quite simple PCBs. I mean, I didn't even put USB sockets on my boards because I wasn't sure how to connect them up to an ESP32. So I'd use things like ESP camera boards where you just plugged in an adapter to do the serial connection. So I kind of just assumed that's what you should do on a dev board and didn't want to get into USB sort of sockets and wiring that up because I just didn't know enough about how it should work.
But this is interesting because some of your projects look kind of quite complicated, like the TV, ESP32 TV.
Yeah,
So
definitely. Well,
you can do software and you just started doing hardware, or what is your background actually?
yeah, so as I say, I did a degree in electronics, but it was mostly software. And then I stayed on for a PhD, and that was pure software. So when I left university, electronics just wasn't my career anymore. It was software. So
Mm-hmm.
then I've spent sort of 30 or so years doing software development. So my knowledge is really around software, and I did
Mm-hmm.
quite a lot of C++ when I was much younger. So building firmware using C and C++ is, I wouldn't say easy, but it's relatively straightforward for me, especially when you have such nice frameworks and libraries to build on top of. So you don't necessarily need to understand the really low level registers. You can use things like Arduino and the expressive IDF, which kind of puts a layer on top of that and makes it very easy to code when you're dealing with quite high level sort of blocks of information.
Mm-hmm. Before we move some of your projects, I'm curious. I've seen one of the videos. There is like EasyEDA crossed and KiCAD is checked. So why
Yes,
is
yeah,
this? I'm
this one,
curious.
yeah. So
Yeah.
this was prompted by I was using EasyEDA because it was just an online tool and it's kind of in the name, it's easy. So I kind of chose that because I thought, well, that must be a clue that this is the one to use if you're a beginner. And I think I hit a problem where I was trying to export 3D models so I could load it into Fusion 360 and build enclosures and boxes for my PCBs. And it didn't have a 3D export at the time. So I was
Oh, okay.
asking people, how do I get a 3D export out of EasyEDA? And then one of my friends on Discord was just sort of, well, you shouldn't use EasyEDA anyway. It's not open source. You should use KiCAD. And then I was kind of, okay, well, I better learn KiCAD because that seems to be what the professionals are using. And I should not use this one that's for beginners easy. I should use KiCAD because that's a proper one. And it had the 3D export and it loaded it into Fusion 360. And I was kind of, this is great. I need to learn KiCAD. So I kind of jumped into KiCAD, and I was actually just looking at EasyEDA earlier today to look at one of my old designs, and I cannot remember how to use it at all. So I think when I started using it, maybe it wasn't so easy, and I was just willing to put in the hours to understand it. But now I kind of know KiCAD. I've almost wiped EasyEDA from my brain. I can't
Mm-hmm.
remember any of the buttons or how you're supposed to use it. So now I'm sort of KiCAD, and it gives you nice 3D exports. But I think
Mm-hmm.
EasyEDA does that now as well.
Yeah, yeah, yeah. I actually, when you started talking about this, I immediately noticed like it's 3 years old, and the video, I
Yeah.
mean, it's 3 years old. So I was thinking like, I don't know how it was 3 years. I don't even know if I was using EasyEDA 3 years ago,
Yeah.
but now it's really good. Actually, I
It
think
is really good.
many people
Yeah.
know I use EasyEDA for some of my tutorials,
Yeah.
and many people ask me why I don't use KiCAD.
Mm.
I actually I wanted to use KiCAD for some of my tutorials, and I started, but then I found out it's going to take too long time because of libraries. That's the
Yeah.
biggest problem. That's like
Hmm.
extremely slow. And if I would like to create a tutorial which is 1 or 2 hours or 3 hours long,
Yeah.
I can't spend 1 hour doing footprints and schematic symbols
No,
because
exactly.
it's
Yeah.
boring.
Yeah.
So that's why I like to use EasyEDA, because you just drag and drop and you don't
Yeah.
need to care about symbols and footprints. And yeah,
Definitely.
they do a lot. Actually, you can even do enclosure, simple enclosure design inside of
Mm.
EasyEDA now. And
Yeah. And I
uh,
think
yeah.
if I was starting now, then I would probably just use EasyEDA, and
Hmm.
I would ignore my friend who was, you must use open source tools, otherwise you're not a real person. I think that was not the right steer now, because
No,
I
uh,
think EasyEDA is great. So
yeah. I think the biggest disadvantage is uh, it's Chinese, and
yeah.
but it doesn't mean you never know who is doing what. Even if it's like a company from US and they ask
Mhm.
you upload your
Yeah.
projects to our cloud, you don't know what they are doing with it. Even like Adobe, you can read all the news
Yeah.
like we would like to use AI to learn from what you are doing.
Yeah. And I
So
think you're right. It is the libraries that really do annoy me about KiCad.
yeah.
It's finding components, having to hunt around to find the right footprint and the right symbol. You do spend a lot of time doing that.
That's
And
why I don't use KiCAD.
Yeah.
I still don't use. I keep watching. I keep my eye on KiCAD.
Yeah.
I'm waiting until they improve component management, and then maybe I will move there.
Yeah.
But I wanted to one more question. I'm sorry for interrupting, or not question, but I wanted to point out many people actually they don't know that EasyEDA it also has a standalone application. Many people think it's completely cloud. There's only one version. They also have like proper software. So if people are designing bigger boards, they can use the standalone application. It's more. It's faster.
Yeah, and I have friends who do amazingly complex projects on EasyEDA.
Yeah.
It is a proper professional piece of software. So I think if
Okay.
people are thinking I should use KiCAD because that's what proper people use, I think that's not true at all now. And I think it's great.
When we are talking about this again, I know some people they as I say, they keep asking me why I don't use KiCAD, why don't keep tutorials about KiCAD. Another reason is KiCAD keeps changing a lot. And that's big issue for me because I create a tutorial and after 1 year or 2 years they will completely change something and tutorial is outdated and but let's move to your projects. I think it's great if people leave comments. KiCAD or EasyEDA, which one is better? Which one do you prefer? Let's leave it to them. And I'm curious about your most popular video, the wireless LEDs.
Yes.
Can you scroll up? Yeah. I remember watching this one.
Yeah, it was. I mean, it is my most popular video ever in the entire videos I've ever posted. It's the most popular. It's the one that's been watched the most commented on. And it's one where I made a massive mistake in some of my kind of here's how it works. Completely wrong.
So did you say something wrong inside of the video?
Yep. I was measuring some waveforms and I was trying to kind of work out how it was working and what the transmitter was doing. And I just completely misinterpreted what I was seeing. And I said, oh yes, this is how it works. It's doing this. And there were a few comments going, no, that's not how it works. I said, you're right. That's not how it works at all. And I was just, but then it was getting so many views. I was, well, I can't delete it. I can't correct it. One of the worst things with YouTube is there's no way you can't go back. You can't go, sorry, everyone, a slight mistake. Even if it's just a little kind of typo on the screen, like you get a resistor value wrong and it should be 1K instead of 100 ohms or something. And you can't fix it. You can't go back and fix your mistakes. But it was a really popular video. I think I was just very lucky that I got a good thumbnail and it caught people's attention and then YouTube just pushed it because someone had posted videos about these years and years ago. Once I'd posted mine, I started finding all the other videos people had posted and there were people going, I posted this 3 years ago and no one watched my video. You've got 1 million views.
Maybe because you made the mistake, then there was big engagement.
Maybe that's it. Yeah, lots of engagement with comments. I think that might be it.
This is actually only the way how to maybe point out mistakes is to pin a comment.
Yeah.
And this happened to me in few videos actually, and in one of them I still remember the comments like, I was screaming when I saw how you connected the button wrong way. And I'm like, no, I didn't notice.
Yeah. It's very, I mean, it's so easy to make simple mistakes as well, because you can misspeak and say something wrong and not notice, and you can do all the editing you want and all the kind of watch the video and watch it again and again. And then you publish it, and then it's the next day you realize, oh, yeah, I said this instead of that. And then everyone's kind of, I can't believe you said that. That's wrong. Okay.
You said millimeters. It should be micrometer. Oh, okay.
Exactly. Yeah. Yeah. And I think it's kind of the same with every PCB I make. I wake up the next morning after submitting it in a cold sweat, thinking, what have I done? Is it right? Go and check the schematic, check everything. It's like, okay, it's fine, it's fine.
But now it's okay. Now it's okay because it's not so expensive. Or like
true. Yeah.
But when I was starting, and some expensive boards, that's problem, because you can actually keep improving and improving and improving. You have to say
Yeah.
like, stop, send it to production, stop.
Exactly. Yeah, I'm doing that right now with my my touch spectrum board. I've got the next version. I think it's finished, but I can't submit it because I keep thinking maybe there's just one more thing I could do just to make it slightly better. And I keep looking at it and staring at it, thinking it's got to be done. It must be done. I need to send this off to get manufactured, but I can't. I can't do it. I think I've caught the fear of sending it off and doing it wrong, and then because it needs to be SMD assembled because I'm not assembling it myself. It takes longer and it's more expensive, and yeah, it worries me now. I've got scared, so I need to get brave and just submit it and send it off.
For me, the biggest problem is they can only assemble 5 boards, or that's the minimum. And basically, usually, I only use 1 or 2 boards, and I don't need the
Yeah,
rest of them.
no,
And I just have to pay for them,
yeah,
and they are sitting in boxes,
hmm
and some of them, as I said, very often because it's cheap.
yeah,
I just make it as quickly as possible, send it to production,
hmm
and then if I
yeah,
need to move something or correct something, I just correct it and order another one. And then I have these previous versions, and
uh,
I'm never going to touch them. And
no. Well, as I was sorting through projects earlier, it was like there's 5 different iterations of the same board. So what do I do with these? Do I keep them for when I'm doing solder pasting so I can basically use them as support for the stencil? It is it's what I think it is one of the bad things about it being so cheap is it is so easy. You just go, well, that's $5 and I've made a mistake. I'll just send off another order the next day to fix my mistake and the next day. And then you think this can't be right. It's got to be wrong somewhere.
but
But
some companies work actually this way, because there are 2 methods how some companies or some people work. One is going and check everything, and it may take week or something. The other way how to do it is just be super quick, build it,
yeah,
fix everything, and build it again. So yeah, I think it's normal.
definitely, yeah.
Okay, let's go back to the LEDs, because you didn't explain what they actually do and what they are. I don't remember. Did you buy them or?
Yeah, so I bought these ones off AliExpress.
Mhm.
I think I saw them on, it was the Adam Savage Tested channel, and I saw them demoing them, and I thought, these look so cool. I've got to get some of those. And I think I ordered 20 of them. Um, and they came, and I was looking at them, and I thought, well, these aren't actually very simple. It is just a coil pumping out EMC or EMI, and then there's just an inductor and an LED across the top to pick up the signal, and they worked really well. I did make in my video, I made a joke about kind of I got one of my stacks of books and stuck them on top, and it was like this is really dense material. It was one of my mathematics books from university. And it even goes through dense material. But they're really fun, and everyone seems to love them. And it is really easy to make your own as well. So I made these ones over here, which
Mhm.
were just kind of these are not SMD ones, and I tried kind of putting 2 on so you'd get both the kind of forward current and the reverse current because it is
Mhm.
a sort of AC waveform. Um, and you can make your own SMD ones. I've got those somewhere as well. Somewhere. Not as popular as the other ones because I think by the point I did them, everyone's getting bored of what
There was
SMDs.
something here. No.
No, I don't. Somewhere in the long list of videos. So many videos. It's got a bit crazy.
Yeah, there
I
was
did.
like DIY LEDs or something. That is that
Yeah.
name?
Where is it? Let's search. No, that's not working. Somewhere, yeah, but you can do SMD ones, and you can get them if you've got a steady hand and good eyesight. Then you can sort of you can get really tiny ones. Oh, here we go. Yeah, oh, that's
Ah,
1.1
okay.
billion views. That was just a
So how do you power them up? You had to buy the coil, or you made it,
yeah.
or?
So you just buy normal SMD inductors. So you buy the SMD inductors, and then they normally have 2 pads on the bottom of the inductor, and you can just solder an LED across those 2 pads. And then as long as you have a coil pumping out at the right frequency, then it will pick up enough current to light up the LED. So
did you have to make the coil or
no,
for
I
the power?
just bought off-the-shelf inductors, and then yeah, they just kind of work. I
But
think
I
because
mean to
it's
power it up, not the one which
oh,
is
to
on
power it
LED.
up. Yeah, so for that I used the coils that came with the original LEDs.
Okay.
I did try building my own, and you can do that as well. So you just need to
Here, see, stop.
yeah, here we go.
Yeah,
Yeah,
that's
so
the
that's
one
the
what I
one. Yeah,
meant.
so that's using the coil that came with the ones I bought on AliExpress. But you can just use a MOSFET to drive a kind of square wave through a coil, and it will light up the LEDs. I mean, obviously, even with the ones you buy on AliExpress, you are pumping out a lot of interference with these things. So I think if the FCC or anyone like that comes knocking on your door, then probably turn it off quite quickly. But it probably is quite short range, so you're probably okay. But it's not certified in any way anywhere. So yeah,
Until your chocolate is not melting or how the microwave
exactly.
was
Yeah,
discovered.
yeah, you feel like your desk is getting warm.
Okay,
Um,
so what
yeah.
is the second most popular project?
Yeah, so the second one was the I
Motor.
started playing around with coils on PCBs. A friend and I, we'd seen one of those haptic knobs that use BLDC motors. So you have a kind of a turn sort of switch, but it has a motor built in, so you can have programmable kind of detents on the switch
Oh
and sort of
yeah. I think there is a
yeah,
very popular. Maybe we can
really
find it.
popular.
There is
Yeah,
very popular project based on ESP32,
yeah,
and it's very cool. I was thinking to do something like this because you can even
yeah.
do like kind of free spin, I think, and
Yeah,
or
it's
you can make
amazing.
it
Yeah,
like you can do whatever you want with it. I think it's very
yeah.
cool.
Really cool. So one of my friends was looking at that project, and I think for quite a long time the motor that was used wasn't in stock anywhere. There were
Yeah,
no
yeah. I
didn't
think
get the
that was
motor.
biggest problem. Yeah.
Yeah, and we had seen what's the guy's name who does lots and lots of PCB coils?
Oh,
What was
you
his
mean
name?
I did video with him. I forgot.
Yeah, what's his name?
Carl?
So
Carl?
yeah, yes, I think that's it. Yeah. So I've seen his videos with PCB coils, and my friend was saying, well, why can't we make a motor using PCB coils? Um, and we sort of got into trying out different shapes of coils. How can we get the most density on a PCB? Um, when you start digging into it, there's a whole area of research into pancake motors, and I played around a lot, and I built a plugin for KiCAD. Unfortunately, that's broken now because KiCAD changes so much, and the
I
API for
told you.
plugin
I told you.
is constantly changing. And there's almost I think I posted on one of the forums kind of, is there a stable API for plugins? And the response I got was just kind of, we're never going to make a stable API. It will always be breaking. So, well, okay. Well, this plugin will work for this version of KiCAD and never work again. Um, so our PCB cores did actually work quite well. We got motors working. Where we struggled was actually with the tolerances on the 3D printed parts to make it work smoothly and have a display on top and feed all the wires through. And we're still at the design stage of that. We've got prototype working, but
Really? That's
it's
interesting.
not
Can
really
we
ready.
search for the projects? Maybe some people would
Yeah.
like to know. Or maybe open could duplicate this one so we have this one still open.
Yeah. It's just
And
so what's it called then? It's a haptic
ESP32,
knob,
try,
isn't
I
it?
don't know.
BLDC ESP32, that might find it. DIY Haptic knob, I think that's the one, isn't it? Yeah, this is the one, isn't it? It's amazing. So we wanted to build something like this, but without needing a motor that wasn't available and building all our own hardware. We got very far. I mean, my friend is much better at electronics than I am and much better at PCB design. He's made a fantastic PCB to mount it on, and he's very good at mechanical design as well. But we still need to do some work to actually get to the point where we can use our motor.
Actually, it's a very good idea to replace the real motor with maybe PCB motor, because anyone can replicate this. I'm very careful about the projects what I do, or these tutorial projects. A friend of mine, he told me like, why we don't put there, I don't know, display or something. I'm like, okay, you can buy a display today, but maybe when someone is repeating this tutorial 1 year later, they will not be able to buy the same display. Like,
yeah, it's really difficult. I do struggle with repeatability of my projects with other people, because I tend to kind of, most of the things I do, I'm doing for my own satisfaction. So it's proving to myself that I can do something. And then you publish it as a kind of, when it worked, and then everyone wants to try it as well. And sometimes it works for you, but not everyone else. And it's quite hard to get projects to the point of being good enough and solid enough that someone else can just pick it up and use it. Because often it works, but only if you're holding it in a certain way, or it works in right light conditions, or it works when there's no electrical noise around. But actually producing something that's good for a tutorial and someone else can run through and recreate is actually a real challenge and really difficult, I find.
This is very interesting you pointed out this, because sometimes I post about the prototypes or very first version what I create, and people are like, can you sell it to me? I would like to buy it. And I'm like, it's not a product. There is big difference between product and like something what you just created for fun. And even like create documentation, it takes so much time. And if you would like to share it with other people, you still maybe would like to do some tweaking, because it's not exactly like you are not satisfied. Maybe you could make it better. So you still would like to make some adjustments before actually you share it with other people. And many people, they don't realize this, like it's not product, it's only something what I built for fun.
Yeah, exactly. It's sort of, and it is that difference, isn't it? It's I made this for some fun, and now you're turning it into a job. And that's not fun anymore.
and the worst part, because writing documentation, that's not like something that I really enjoy doing. But I have to do it because if someone asks me 1 year later like how to do this, I'm like, okay. So I'm very careful about this. I always upload everything to GitHub, and you know, I stage project properly, like this was sent to production, and I can always go back and, okay, this is what you can replicate and build it. Okay, what is the third one? Printing PCB at home.
Printing PCBs at home, yeah. So this was, this came, one of my friends had, he brought a Volterra machine, which is a PCB printing machine. So it basically prints out conductive ink. So actually we can show you how it is.
I'm not sure how much we can play, because YouTube will flag my videos there.
Oh yes, let's not do that then. Yeah, good point. But it this Volterra printer. So basically, it prints conductive ink onto a PCB substrate, and then you bake it on the machine, and it turns into conductive traces.
Is it good?
It's okay. It's quite fragile. So if you have kind of connectors and stuff, then eventually they will snap off, and it kind of wears off over time. So if you can't use it for anything that's under mechanical stress. It is pretty good. So this was an ESP32 board, so it's good enough for kind of quite small sort of components. It does quite fine pitch, and then it also prints the solder paste as well, so it will do solder paste dispensing.
It was my next question, actually. How do you solder it down? So you don't use like soldering iron, but maybe you bake it.
No, you have to use special solder.
Low temperature.
Low temperature solder, and you have to use special solder paste as well. So the conductive ink is silver based. So I think if you use normal solder, then it sort of leaches the silver out of the traces and stops it working. So you have to use special solder paste and special conductive ink. So it's good for prototypes, but again, the problem is you can get a PCB prototype for $5, and if you're in a rush, you can get it shipped to you sort of in a few days. So the machine's really fun and really cool, but it's not very practical. So
I have exactly same opinion. I think I watched this video or maybe something similar on the same topic, and I was exactly thinking this, like maybe 5-10 years ago when I don't know, PCB weight didn't exist or JLC PCB didn't exist. Okay, but now next week I can have PCB.
Exactly,
like,
yeah. And
nice PCB.
yes, and there's a lot of it's like 3D printing, but 3D printing back when 3D printing.
So you have to experiment. Maybe sometimes it doesn't work exactly as you. Okay.
Yeah, and sometimes the nozzle gets clogged and it doesn't print out any ink, and then you have to replace the nozzle because it's blocked and there's no way to unblock it, and the ink's very expensive. So it's yeah, I think now it's not really necessary unless you really need a PCB prototyped right now. Then it's kind of just a bit of fun, I think.
But then people also can use the CNC machine to create.
Yeah, exactly. Yeah. So, and lots of people did say you could spend that money on a CNC machine. It would be amazing, and
you can do even more things.
Even more things, yeah. So I wouldn't have brought one. So it was only because someone had one as a spare thing on his shelf and said, "Do you want this?" I thought, but it's kind of rude not to take one and play with it. But I've used it maybe 3 times in the time I've had it, and it's currently acting as an extra shelf for other projects that have been piled on top of it. So it does have quite a big hot plate, so it's quite good for reflowing larger PCBs because all I have is a mini hot plate for that. So that's quite good, and it will do reflow of normal solder paste. So
okay,
good for that.
So we talk about the next one. What else you have there?
Yeah, so let me get on to more kind of interesting projects or more.
I will pick one, okay? TensorFlow and AI. Okay, on my channel, AI is not like very popular. I don't know why. USB cable tester. I was looking into this project. Did you build it or?
I built this. It's another one I saw. I think I saw it on Andreas Spy's channel. He showed a USB tester, and I thought, oh, that looks like something I could definitely build. And it took me 2 goes to get something that was actually working because it's really hard with USB sockets that expose every single pin. The pitch is just ridiculous on them, and most of the pins are hidden underneath the socket, so you can't see connector. So it was a complete nightmare actually getting it to work. And in the end, I found a USB socket that had exposed pins for half of them and then normal through holes for the other pins.
Yes, that's what I actually decided to use for measurements.
Yeah, because I just could not solder it at all. And every board, I would just do it. You'd plug in the cables and all the lights would light up randomly and be like, oh, I know this cable doesn't do all of these things. But it's really, really nice. I think it's got popular because it just looks really nice and colorful.
It's useful. It's super useful.
Really useful, yeah. So I ended up actually buying a really expensive cable just to test all the LEDs. I wanted to see if it actually did work.
Did it work?
And I bought this unbelievably expensive cable that did light up everything. And I was kind of like, I now have the best USB cable in the world.
Do you know what was the brand? I'm just curious. Is it this Belkin one? What was the brand?
No, it wasn't the Belkin one. Or maybe it was actually, because that does seem to have most of the
Not all of them. D plus, D,
all of them,
D minus.
Yeah, somewhere in my collection of cables,
Okay,
I have a really expensive cable. It's in my, I think everyone's got a drawer of cables. It's in my drawer of cables somewhere.
Okay, and did you create this from scratch, or you found the original project?
Do you remember the original?
You designed this?
It's for sale. It's on, I think you can get it on Tindy.
I think original design is from someone from Austria, or
yeah, that's right. Yeah, I think so. Yeah, Yeah. So I just did it from scratch because I just thought it's a nice, enjoyable PCB project, not too complicated, almost more of a kind of layout challenge. So I find sometimes laying out tracks on PCB is quite therapeutic. So you're just sort of, you can just get into a nice Zen-like state of kind of routing tracks, and it's kind of fun puzzle to solve sometimes of how do I route this in a sensible way? How do I get all these tracks? It's a nice challenge, I think. I don't know. Maybe that's just me, but I kind of enjoy that. So yeah, I just made it from scratch, and then I just got the PCBs and then spent a long time placing tiny resistors and tiny LEDs on the board and then reflowing it and hoping it would work.
So
But it was
there is
nice.
battery from the bottom side, or?
It's a battery on the bottom, yeah.
Mhm.
So there's a coin cell battery on the bottom. So it was definitely heavily inspired by the Austrian guy's version. So I just looked at it and I thought,
Can we
that's
find him
something.
so he gets the credit?
Yeah. Can you, if you find him,
I don't
put
know,
a little.
USB cable tester. Just try to
USB.
search like
Yeah, let's have a look.
open or yeah, it's like this. Maybe project.
So,
Maybe put there like project or.
look. Where images would be a good.
Yeah.
Oh, there we go. Is that the one?
There is yours, Ada free vlog, no? There's yours.
Yeah, that's. Yeah. There's. Oh, this is the one. I think. Yeah, this is the one. Yeah. So yeah, it's this one. So Chris Lott. Does that seem right?
That's the author of the article, I think. Maybe.
Ah, okay. Yes.
Has designed.
Peter Tramuller. Yep.
From Austria. Yeah, I was right.
Pronounced terribly, but.
Because I think he sent these to Dave Jones from EV blog, I think, and
Right.
they've reviewed these.
Yeah, it's really nice. I mean, I just made it because I thought I can make that on a PCB, and it's like it'll make a nice YouTube video of let's make a USB tester. Here's a PCB.
I was actually thinking exactly the same,
Yeah.
but then I did something else.
So,
Okay.
I think his one, yeah, his one's got more than I've got, but yeah, so that was a fun little project.
Next one, ESP32 MP3 file.
Yeah. So this was actually one of my friends who he does some consulting work for a robotics company for a school, and they were trying to add audio to the robot, and he was kind of, is it possible to play MP3 sort of files on an ESP32? And it was one of those kind of probably, and I found a very old bit of C code that decoded MP3 files, and then it was just kind of plugging it together. And it was one of those projects that just kind of worked. You just kind of like, I didn't expect it to work at all, but then I'd already done lots of audio on the ESP32, so I already knew how to get audio out. And it was just a case of kind of, well, I just need chunks of audio data to feed into the I2S interface. And this bit of code reads MP3 files and gives me 128 samples at a time. And I can just feed that in and it just magically works. So it turned out to be really, really simple. And I think it was popular because audio seems to be really popular on the ESP32. Everybody wants to do some kind of audio project. And I don't know why. Maybe it's just a nice thing to do because you get some kind of physical sort of output from the device. It's I don't know what it is that makes audio so popular.
Do you use like SD card or how do you get the data?
So I think this was just on SPIFs. So I just uploaded a very tiny MP3 file SPIFs. I think somewhere I do have a video with SD cards.
On your TV.
There we go. So yeah. So that was kind of, so I did a lot of audio stuff. When I first was starting out on YouTube, I was playing with the ESP32 and because it supported audio output very easily, it was kind of, well, these are great projects, and digging into how it worked, I got very, very deep into kind of what are the settings you should use and what are the trade-offs. It was just, me, it was very interesting just learning how to do it.
You know what is very interesting? You have many ESP32 boards, and I get questions like, why do you use ESP32 all the time? Why don't you use STM32 or something? And I'm like,
Yeah.
I like Wi-Fi, I like Bluetooth, and I like copy and paste from all the examples which are already on
Yeah.
internet.
I think that is it. It's actually someone I was thinking the same question the other day because I was on my latest project. I started playing with an RP2040,
Yeah,
and
me too.
I was thinking kind of, well, I've already got an ESP32 on my board, but the RP2040 is actually quite good, and it does all these things that I can't do on the ESP32. But then I was thinking, but Wi-Fi and Bluetooth, that's really good. So I may actually end up having both on the board now. I'm tempted to just put an RP2040 on the board as well. But I think the ESP32 is just seems very accessible to people. There's so many dev boards. It's so cheap to get a dev board that
And so
anyone
many
can get
examples.
one. So many examples as well.
There,
Yeah,
there is almost everything. Like you can, because even sometimes you only would like to prove an idea very quickly.
yes.
Like, is this going to
Yeah.
really work? This is actually, this will be one of my next questions. We will talk
Yeah.
about this. But sometimes you would like to do this like very quickly and find out as quickly as possible, okay, this is not going to work.
Yeah.
It's not going to be what you imagine. And then this is super useful. And once you prove your idea, then you can play
Yeah.
maybe even with different microcontroller. But first, make it as quick as possible.
Exactly, yeah. And it is really quick to write a program for the ESP32. If you're using the Arduino libraries or the IDF, both of them are quite quick to get going. If you're used to it, then you can create a project very quickly, and yeah, you can prove if it's possible. And
Let's go up because I noticed you used in one of the projects a little bit more. This one, ESP-Now. So I
yes.
notice many people talk about this and they are saying like, don't use Wi-Fi, use ESP-Now. So what does it mean?
Yeah, so it kind of uses the same frequencies as Wi-Fi, but it's a different packet structure, and it's a kind of mesh type network. So it's a device to device type thing. So you can actually set it up with one ESP32 as almost like a router for other ESP32s, but it's an ESP32 to ESP32 communication protocol with quite small packets. So there's some really good use cases for it, but it's not a replacement for Wi-Fi. So you can send data over it, but it's tiny packets. I did on my walkie-talkie project. You can use ESP-Now on it to send the data, and it does work. But it's quite cool. It's very interesting to play with, but it is one of those technologies that's specific to the ESP32. So it's an expressive technology that they've got the protocol. I've seen some open source implementations. So I think on Linux you can set up an ESP-Now sort of compatible thing, but it's very much an ESP32 technology. But it works great, and you can just set it up and they start talking to each other. It's really fun to play with because
does it really work on 500 meters?
It did, yeah. So I walked around. Our house looks over a park, so I spent a long time walking up and down in almost a grid pattern in our local park, checking the distance, and it did go out to kind of quite far. So 500 meters was doable. You do start losing quite a few packets, but some packets do get through. So it's definitely quite line of sight. So if you've got lots of trees or bushes in the way, then it won't work, but it will work out to quite a distance. It's it's very, very impressive.
Maybe I should play with something like this.
Yeah, I mean, it's definitely tutorial worthy because people absolutely love it and want to try it. It's very popular. I still get questions about ESP-Now and how it works and how did I measure the range and what's the code I used. And
I'm telling you, I notice more and more people actually using it. Okay, I remember I watched this minimalistic microcontroller building there. But is it the one where you solder everything on the other side?
It is, yeah. Yeah, I got so many comments about how terrible my soldering was. And it was just kind of lots of people saying you shouldn't use this in production. It's kind of like, well, I wasn't planning on using this in production. Yeah, lots of complaints around my soldering. Lots of, you're a terrible person for even putting this online, and why aren't you ashamed of what you've done?
Because
But
I was thinking doing something similar, but maybe using simple PCB.
Yeah, so I
really
did a
properly.
follow-up somewhere where I made it kind of made me think about sort of you could make a really tiny ESP30. Here we go. So this board here is actually the size of an ESP32. So there's an ESP32 on the back. And
this is exactly my idea.
yeah. And it was a really fun project because it was initially I was sort of you can't fit enough stuff on the back of a board to do this. But actually there's an audio amplifier, and I think in one version there's a battery charger, audio amplifier, and the kind of regulator, and a couple of LEDs. It's kind of, so there's a lot of room on the back of an ESP32. So yeah, a little board is definitely doable.
Did you use like vias in path or how?
No. I mean, and it's just a module on the back, so it's an ESP32 module on the back. It's not going to show me a preview, but yeah. So there's a surprising amount of space to fit lots of stuff on. I think in the end I actually connected a speaker and a display and made a little TV. That was the start of So this project here, that's using that same board, but I've got an SD card and a display and a speaker attached and a little screen, all on this tiny PCB. It was great. I just kind of thought, I think I'd seen someone else's tiny TV, and I had this tiny board, and I thought, well, I've got some tiny displays as well. I can make a tiny TV. This would be great, and it worked.
But it's not like I think it's not like proper TV. It's not receiving the
no.
signal.
It's just AVI files on the SD card, so you have to upload videos to it. But it did trigger another project where I was playing with this, and one of the slightly annoying things with it is the ESP32. It's got quite slow USB, so it's not USB 2. I think it's USB 1 dot something, but it means it's limited in the speed you can copy files onto the SD card. So you can put the ESP32 into mass storage mode and have it writing to an SD card, but it is very, very slow. So I started another project where I thought, if I'm going to make a TV, you want to be able to upload videos to it really easily. So I ended up having a USB, I can't find a picture of it, but I ended up with an ESP32 connected to the SD card and a mass storage controller with USB interface connected to the SD card, and then some crazy way of toggling between the two. So I would disable the ESP32's USB, so this mass storage controller could take over the USB and then talk to the SD card and upload files really quickly. It worked really well. I was really surprised that I think the first version didn't work. It just would not work. And I realized I'd connected the enable pin the wrong way up. So it was always enabled, both the chips trying to talk to each other at the same time, and nothing worked. It blinked briefly, the light came on, and then just nothing worked ever again. I think
this is how everyone learns. It's part of the learning. Enable signal. And swapping UARTs.
I think I blame it on the datasheet not being clear. There was a pull-up resistor on the enable line, and I had a pull-down resistor externally, thinking I'll just pull that down and that will work. But because there was a pull-up resistor, my voltage wasn't enough to actually disable it.
I think I've seen it in one of your videos, no?
Yeah, there was a video I did on it, which somewhere there'll be a video on there.
This is one of the classic mistakes, actually. That's why I remember once I suggested Altium had these like feature requests, And very, very long time ago, like I know 10 years ago, I suggested like, please put their option like show the internal pull-ups and pull-downs. And they actually
Yeah.
implemented these like,
Oh,
I
that's
don't know,
good.
1 or 2 years ago.
Yeah.
I don't remember. I've seen it somewhere.
Yeah, I wasn't that upset. I was a bit annoyed because I was just kind of like, if it hadn't been for that, this board would have worked first time.
Hmm.
And instead I had to put some bodge wires on, which somewhere there's a video of it, but yeah, it's somewhere in the long list of videos, there's a bodge wire. Oh, here we go. No, that's my board that I blew up. So many bodge wires.
Let's
But
talk
yeah,
about this keyboard, the
so
Spectrum.
the touch spectrum.
Yeah, yeah,
So
yeah,
this is
yeah.
my current project that I'm working on, and it came out of the Tiny TV project because I was playing around with it and I thought I've got a screen, and someone had shown me that you could connect Wii nunchuck controllers over I2C, and I thought, oh, well, so that's a controller. I could make a little tiny arcade. And I thought, oh, I remember the Spectrum. I had a Spectrum growing up, and I thought, I wonder if there's a ZX Spectrum emulator for the ESP32. I
And there is.
found one. I thought, yeah, I'll try running this on my little tiny TV, and it worked. And I was thinking, oh, this is great. I could make a little, a tiny ZX Spectrum. And then just as I was playing around with that, the full color silkscreen printing capability starts to be announced. And I just thought, if there's one keyboard that really needs full color, it's the old Spectrum keyboard because there's so many stupid things on it that if you zoom in a bit, it's no, I've lost it.
You
It's
you
got
can you can now order it based on date because I think it's yeah, okay, you found
yeah,
it.
there we go. Yeah, so all the different commands have different colors. So you have green text and you have red text and you have these nice blue colored things, but they've got red text and green text on them as well. And you got the colors up here. So it was really kind of wow, I could actually get this printed on a PCB, and the ESP32's got touch pins, and you can matrix the touch pins. And I was looking, I thought, oh yeah, you could. I was reading all the docs on the ESP32 GitHub thing about how to use matrix touch pins. I thought, yeah, this could work. And I looked at the ESP32 how many touch pins it had, and it didn't have enough. And I was just, oh, I can't do this project. And then I looked at the ESP32 S3, and they added more touch pins. And I thought, I can do this now. This is actually doable. 13 touch pins will give me 40 keys.
Hmm.
So I can actually do 40 keys, which is exactly the number the Spectrum needs. So my initial version was just a matrix keyboard using 13 touchpads and the color silkscreen printing.
I would like to
And
point out this. So these are not real buttons. These are just
oh no,
touch
these are
pads,
just
and there is
touchpads.
colored
Yeah,
overlay,
so it's just
or is it?
touchpads.
Yeah,
Yeah, so it's just capacitive touchpads
so
on the
it's just
PCB.
PCB.
Yeah, so it's amazingly cheap to manufacture. So the actual cost of the PCB and the full color silkscreen printing it's still if you look at quotes for kind of mass production, it's kind of like a few dollars still for the boards. It's not expensive, and there's no moving parts, no
Yeah.
switches, no rubber keys to wear out. So, but of course, I got the first version, and because I was using the Matrix touchpads, you could only really touch one pad
Yeah.
at a time. And the keyboard on the Spectrum is all about touching multiple pads because you
Hmm.
need to get the different
I've seen
modes
your
and
next.
weird
I
modes.
follow up video.
Yeah. So all the games, of course, you start getting horrible kind of clashes between keys. So you're trying to jump around and you're not jumping around, you're moving left, or your speed's decreasing because you're trying to fire and go up at the same time. So yes, I had to do a bit more thinking about that. And that's why on this version there's 5 more ICs along the top here, which are these are analog multiplexers. So I ended up multiplexing the analog touch signal out to each individual key. So every single key is now its own touchpad and gets multiplexed back to the ESP32. I'm still amazed it actually worked. I can't quite believe it worked. I built it on some breadboard to test, and it worked. And I was sort of, this really shouldn't be working. This is not. I'm sure whoever designed the touchpads on the ESP32 wasn't thinking somebody's going to try and run this
Multiplex them.
because it's just not right. But anyway, as always, if you look on the picture here, there is a bodge wire going from the SD card to the Raspberry Pi. That was one little mistake on the board that I made. But yeah, so it was really fun. So I am actually, it's one of the few projects where I've actually, people have said, can I buy one? And I'm actually going to try and productionize it. So I'm trying to get it on crowd supply at the moment because I think it might be quite a nice thing. I need to do more work on the software. The software is not finished yet, but it works. I'm still amazed it works so well. The keyboard is really responsive. It's great, and it looks fantastic. I've never seen a PCB that looks so nice. It's really nice.
I've got. I think I noticed on your channel you use PCBWay. Yeah.
Yeah.
They do it too, and
They do it too, yeah.
I know JLC PCB they do it too. I
Yeah.
don't remember. I know JLC PCB right now. I think they only support it from EasyEDA. So how PCBWay do this? I think they apply picture on top of it, or I don't remember.
Yeah, so it's still a beta process with them. So there's still some rough edges to it. So what you do is you send some high resolution artwork. So I send a transparent PDF keys on, and you send instructions on where to place it. So my approach has been to just take the size of the PCB and create an image that is exactly the same aspect ratio but high resolution, and then just tell them just to draw it on top from just the whole PCB. So because they were kind of suggesting that you should send instructions on the positioning of where to actually draw it. And I thought that's going to cause lots of mistakes. So
you just draw the board outline,
draw the board outline,
and then put this image on the board.
And I've done it. This is my third iteration. So now I think they know exactly what I'm asking for. The first time there was lots of back and forth and communication of sort of what are you actually asking us to do? How do you want us to print this? And because it was a transparent image, I had some white text, and they were saying, well, we can't see the white text because the image is transparent. It's kind of, well, it's definitely there. There's definitely some white text there because I can see it here. And there was lots and lots of conversations around kind of, well, here's a version with a background so you can see the white text. It's definitely there. I go, okay. Yeah, we can't see the white text. So why can't you see the white text? And then they sent me one version where I'd given a mock-up. I sent them a mock-up of what it should look like. So they printed the mock-up on the board. It's kind of like, no, that's not what I wanted. that's the mock-up. Here's the artwork. So it's definitely a beta process, but I'm quite impressed by the quality of it and how it comes out.
Same for me. Yeah, I've seen so many PCBs with these colors, and they are like very nice.
Yeah, it is really beautiful, and it's
actually when I visited PCBWay, I've seen how they do that.
Oh, I'm really interested in how it's done. I imagine it's a really manual process of someone putting PCBs into a
but I think they told me they actually are going to use different machine.
Interesting.
So it will be easier, I guess. Maybe they only somehow tested it initially if there is interest, and maybe they noticed like people would like to have this kind of, so they decided to invest maybe into better technology or something.
It's really, I mean, I'm quite impressed that they've managed to do it, because printing kind of colored inks that are stable on all the temperatures and the processes the board has to go through, it's a real kind of
I think it's the last step. I think if I remember right,
last step?
It was like a real printer. They put there the PCB and they print every color individually, I think.
Yeah, interesting. Yeah.
If I find the video, I will post it somewhere.
Yeah, I need to watch it. It's great. So I've been really pleased with the output. But I think lots of the PCB manufacturers are now offering the service. So I think now sort of one or two of them have worked it out. It's going to spread very quickly to the other manufacturers, and they'll all be doing it. But yeah, I absolutely love it. It's great.
Me too. Okay, so what else? What are the other projects? I think these are the projects what I noticed on your channel. I watched all of them. So let's order this based on the latest project now. Which one?
Yeah, so let's
go. Oh, I seen there was the paper display. Like,
Oh, the ePaper display, yes.
what is
That
your
was
experience with paper display? Because my,
um
it was kind of okay, but the driver,
yeah, the drivers, it's really, it looks fantastic, but I'm just trying, there we go, yeah. The drivers, they're just not very good. And it's sometimes the boards aren't very good either. And I was trying to use deep sleep. So I was trying to go to sleep because I wanted almost a Kindle equivalent that would last for a long time.
mhm.
And it isn't the paper displays are amazing because the image just stays there. You can turn off completely, the image stays there. But when you come back, you're always in a slightly weird state because the paper has maintained the image. And unless you've kept track of what's on the image, you have to do a completely blank the screen,
Yeah.
all the drawings and refreshing to get it completely blank. And then you can draw another image, which tends to take a really long time. So it's a really slow process. So you can come back from sleep, you push a button saying next page, you come back from sleep, and then you have to sit there for 10, 20 seconds while it moves to the next page. So most of my time was spent just trying to store the state of the current page so
Mhm.
that I could switch pages really quickly.
Mhm. So I would like to mention, if someone never used e-papers, there are actually, first, they are quite available. I think I bought
Hmm.
mine on, what is it, the Chinese Wave? Where did you buy it? Which one did you buy?
This one was an M5 paper. So that was
Right.
from, I think I got that from AliExpress.
AliExpress. I used
Yeah.
someone else. I don't remember what is the name. Can
Yeah.
you
So
just
this
search
was,
for ePaper, buy ePaper or something?
yeah. The Liligo one as well. It's very good.
Mm, it's none of
Wish
these.
it-
It's none of
the,
these.
if you go on AliExpress, there are lots and lots of them.
Hmm. But I don't buy from AliExpress because then you don't know
No.
when they will stop selling them.
See, Amazon have them. Wave shares the big
Yeah,
manufacturer.
that's the one. Yeah,
Yeah,
that's what
Wave
I
share.
meant. Wave share. Yeah,
Yeah.
yeah.
So they have lots and lots. But I also got a box of e-paper displays that are used in shops. So the ones that are on the shelves. So someone
I
sent
was
me a
very
box of those.
surprised actually, until I've seen these in Singapore.
Mm.
Only after that I noticed they actually use them also in Slovakia. I had no
Yeah, I've
idea.
seen them in Europe. Yeah, I think in the UK we're a bit behind. I haven't seen them anywhere in the UK, but been over to Europe and I've seen them in quite a few places now.
But you know
Uh,
why? Because, for example, in some shops, they use them only for some goods. The one what I mean is what I've seen in Slovakia is only used for vegetable and fruits, and they maybe
Interesting.
upgrade it every day or I don't know. But in
Yeah,
Singapore, whole shop had everything in
right.
on
Interesting.
e-paper. Like,
Yeah. So that was a really fun project, but that really was mostly software. It was all software.
mhm.
So a lot of it was one of the things with EPUB files is actually an HTML file. So displaying it's quite difficult on a low powered device that doesn't have much RAM. So a lot of the work was just taking this quite horrible format and turning it into something that could be displayed easily. It was a really fun project. It is, and it
This
is
is the one which
fun.
is used in shops or no? Because it looks almost like. If you go back to ePaper images, what we've seen, I will show you what I've seen in. Go just on images, yeah. Uh,
So
just
this is
ePaper,
cool.
maybe put there ePaper,
Yeah.
yeah. Which are the ones what I've seen in shops? Oh, I see. The first row and the last one.
Yeah. Yeah, there we
Last
go.
one, last one, last one, last one.
That's one.
Yeah,
Yes, that's the ones from shops.
yeah.
Yeah.
So they have the
Yeah.
barcodes, and I think you can
Mhm.
talk directly to them.
Yeah. Yeah. So the one I'm using is a commercial one. So that is the M5 paper. I think this one might be this is a is that the same one or a different one? Someone sent me a board that was quite nice. It was someone making their own boards. So I tried out that. Yeah, they're really, really good fun.
So
Yeah, I think
MP5 paper, it includes also the frame?
includes you can buy the frame in addition, and it's got an SD card reader and it's got some toggle
Can you search
switches.
for it? I'm curious.
Yeah, let's look.
M5 paper.
Yeah, this is the one. So it's quite nice. It's got a lot of lots of stuff on it.
And there is ESP32 already built in inside.
Yeah. So it's quite a nice board. I think it's got a speaker as well. I don't know.
I had no idea something like this exists. How much does it cost?
This one,
85.
quite expensive, $85. So it's not cheap, but quite nice.
And they also provide some kind of software, or how do you program these?
They've got a library for it. Someone's written an ePaper display library, and I think I used that one.
So you use like Arduino environment and just include the library and...
Yeah, exactly, yeah. So I think it might have been this one. Yeah, so there's some open source libraries that, yeah, I think this is the one. I remember this EPD thing. Yeah, so there's quite a few open source libraries that will drive them. I think one of the big problems is reverse engineering the waveforms for actually driving the boards is quite complicated.
Yeah, that's what I had problem with, because actually I think I remember I ended up trying to find the data sheets of the controller, because there are many registers, and any small changes, they actually influence how durable the picture was, or how black it was, or I don't remember exactly, but yeah.
Yeah, I think this might be the guy. I know there's somewhere there's the actual driver code. But yeah, it's quite, is it called, maybe not this one, Open Weather Map? No, I don't know. But yeah, there's some quite good drivers now that will drive ePaper displays from the ESP32.
Okay, if someone would like to play with ePapers, it's possible. It's not so difficult.
Definitely possible, yeah.
Actually, my son was doing this, and I think at the time he was like, I don't know, 15.
Yeah. Yeah, so that was a really fun project, and I was quite pleased with the output. I mean, it's not a commercial production project. It's not a replacement for a Kindle. If you have a Kindle, keep your Kindle and don't replace it with my DIY e-reader. It's not a replacement.
You know what we used, or the original idea behind this project, what we were working on, was we live in apartment building, and it means once a week someone else is cleaning the common spaces.
Yeah.
So I wanted to make this ePaper like this week.
Right.
You are cleaning.
Yeah. Yeah, I've seen quite a few used for meeting rooms in kind of shared offices with ePaper displays on the doors. Yeah, they're quite fun. I do like ePaper displays.
Okay, next. Next one, what you liked? What do you really liked?
I really liked. Oh, there's another ePaper one. So someone sent me this ePaper display, which was nice. I really one of my favorites was the DIY Alexa, which was a bit of machine learning and fun stuff. So where's that? That's somewhere. That was way back. Somewhere. Yeah, my DIY Alexa, I really liked it mostly because I found some sample audio for training something. And one of the audio samples was Marvin, which is the name of the robot from The Hitchhiker's Guide to the Galaxy. So my Alexa keyword was Marvin. So you'd say Marvin, then it would wake up. And then I think I even added in his voice of, I could make him say, here I am, brain the size of a planet, and all you've asked me for is a joke. So that was one of my favorites. It was another one that I thought this probably can't work on device. And there was a lot of, when I was doing it, most of my kind of time was training a model that would be small enough to fit on device and run quickly enough. And I was constantly kind of, I don't think this is going to work because this model is getting really, really tiny. It's not going to work. It won't be accurate enough. But it actually worked surprisingly well.
It does.
It kind of triggered the voice command robot as well, because in these audio samples, they were sort of left, right, forward, backward. So I was able to get the voice controlled robot working with pretty much the same code and all the same training steps. So both of those were really pleasing because I was learning about some machine learning stuff that I didn't really know much about before, and it worked, which was even better. That's what was most pleasing. It just actually worked.
Actually, I played with this. I just haven't done any video about this because, as I said, I remember for some reason people don't like AI stuff on my channel, but I played with ESP32, and I think I used the TensorFlow. What do you have here? Like, I think TensorFlow, and it was not difficult. And exactly as you said, I remember, I think I used like maybe 10 samples to teach it a few words. It could do it somehow, not every single time, but maybe if I recorded 100 samples, it would be much better. I don't remember.
And again, it's not perfect. So particularly the voice controlled robot, it will just kind of start running around by itself after a while. And sometimes it goes right when you say left, and left instead of right, and it's not very obedient as a robot.
Actually, my original idea was it was project which I proved the idea. So the project was about toilet. So sometimes toilet gets stuck when you flush the toilet. It gets stuck, and then the water just keeps flowing. I don't know if it's. I think it depends what kind of system people use in different countries. But in Slovakia, it can very easily get stuck when there is, I don't know, the water. What is it? Scale, or how is it called?
The scale.
Scale, and it gets stuck. So what I did, actually, I used ESP32 and microphones, and when the water was running, it was listening, and it knew like water is running.
Interesting.
And then when it stopped, I wanted to use the machine learning to recognize like water is running and water is not running. But then I just ended up with a filter.
Yes. I mean, sometimes that's a bit easier, isn't it? You don't need machine learning for some things.
And I was very surprised. Actually, it worked very well, but I never finished it because there was not like big interest on internet about this project. But
I know someone who he built an IoT monitor for toilet paper. So he had a distance sensor checking how far away the toilet paper was, so you could see it going down. And they had a chart showing different usages of toilet paper.
Really? Like you are using too much toilet paper.
Exactly. Yeah. That was a lot of toilet paper. What's happened?
What did we have on lunch?
Let me try and find it. It was the toilet paper IoT. What would it be? That might be enough. Yeah.
Oh yeah.
This is not the same one, but it's a similar one. Yeah. So you can track your toilet paper usage. Let me find the. It was a local university lecturer. So here we go. So there we go. His toilet paper data. There you go. That's over time how much toilet paper gets used. So you can see someone's. They're very interesting. A very simple monitor there, working prototype, and You have to,
We
so
suppose.
here's ran out, so half used. I like the runny nose. Someone's got a cold, so they're using cleaning up after the cat. So that's a project for someone to try out. That's
Interesting one, yeah. Okay, let's go back to
yes, yeah. And then my other favorite one was
game
the laser
controller.
projected asteroids.
Oh, oh, I watched this one. This was really
Yeah,
cool.
I
First, I
really
actually
enjoyed
didn't
that.
understand how you did it, but then because I never watch whole videos. I just
Yeah,
click.
no, who watches the whole video? That's
But
I
then
mean,
I found out
everyone
there
on
are the
YouTube.
mirrors.
Yeah, anyone on YouTube watches the first 5 seconds and then skips ahead.
I wanted to see the finished project.
Yeah, so I was really pleased with this one because I had to make a little controller. So I made a 3D printed controller. I had my custom PCB for doing the actual driving the galvos and plugging into stuff. Um, and then I kind of built a nice box for it and a power supply. So it was we could hit that. You can see the
Let's
thing
play
now.
a
Let's
few seconds, 3 seconds or something, so people know what it actually does.
do this one because yeah. So here we go. This is
Yeah,
it's got sound as well. Look at that sound. I've muted it.
it doesn't play sound here anyway. So
No, okay, well, it's fine. Yeah. So yeah, it was really cool, and it works really well. It's very hard to film, so I had to really play with the exposure levels because it's the frame rate's not actually that fast. It kind of coincides with the camera frame rate quite badly. So depending on the shutter speed, it it can kind of look very flickery, but the actual in person, it looks really amazing, and it was a really fun project. And I remember playing Asteroids as a child, so it was like recreating something I'd seen as a kid, and then and playing with it. It took one of the biggest challenges was drawing text in a really efficient way. So I had to create my own kind of terrible font that only had a certain number of points on it. So you can see a P, very square, same with an R. It's all kind of straight lines to minimize how many points you have to go through to actually draw it.
So I would like to explain. So basically how this, or you can explain how it works.
Yeah,
Maybe
so there's
there are two mirrors, which
two
are
mirrors. Yeah,
two, I don't know.
so there's two mirrors. So what it is it's a laser galvo. So let's try and find a good picture. So what you have, yeah, here we go.
Yeah.
That's quite a good picture. Oh, where's the picture gone? So you have these this thing here. There's two, they're not really motors or servos. They're actually sort of coils with a magnet around them. So you energize the coils and that turns the mirrors. Find a shot of the mirror. Let's go back, find a different picture. So yeah, basically you have these two mirrors.
It's the first one.
That's one. Yeah. Okay.
Yeah,
Yeah.
there are the mirrors.
Yeah. So here's the mirrors. So so these are two mirrors, and then these two galvos, you drive those, and they move the mirrors in the X and Y direction, and then your laser reflects off the first mirror, and that gives you one direction, and then it reflects off the second mirror, and that gives you the other direction. So you have XY control of where the laser is pointing, and then you just drive these to produce the pattern you want, and turn the laser on and off quickly enough that you get breaks in the line. So they're really cool. I mean, one of the difficult things is actually driving these galvos. So you get these driver boards that can drive these at really high speed. And there's all sorts of potentiometers for tuning the parameters and overshoot and undershoot and dampening to get the fastest speed you can without getting really wiggly lines. So it's quite a challenging project. You can get really expensive versions of these laser galvos. So they go up to thousands of pounds for really high-end ones. But it's actually lots of 3D printers, the ones that print using resin, use laser galvos for drawing the picture. So some of the old ones would use a laser galvo, just like this one, for actually drawing with the UV laser onto the
Oh,
onto
I
the
didn't know.
resin to
So,
get the
uh,
layer.
what I was thinking about when I was watching the video, like, do you somehow algorithmically find out what is the most optimum way to draw the, or you scan it and then draw only?
I tried a few things to sort of sort objects so
Mm-hmm.
that I drew objects that were near each other, which kind of helped a bit. Um, it is really it's really hard to get it to work well because if you drive it too fast, then it just overshoots and you end up with terrible lines. But if you drive it too slow, the refresh rate
Mm-hmm.
gets very flickery and you're drawing very slowly. So I think it's a bit of a kind of bit of an art in actually tuning the parameters to draw quickly enough.
So you
Uh,
draw the objects one by
yeah,
one.
you draw one by one. Yeah, so each one's drawn individually, each line segment drawn, and you have to draw slowly enough that you actually get a line segment drawn. Because if you move too quick,
Mm-hmm.
then you just get a gap or you get a
Mm-hmm.
very faint line. So you have to
Mm-hmm.
draw, and then move to the next one really quickly with a laser off, and then draw. So it's another project that when you're building it, you're thinking, I don't know if this is going to work. This probably won't work because I don't know enough about control theory to really know what I'm doing to drive this quickly enough. And you're completely reliant on these very cheap controller boards that come with the laser galvos that have all these potentiometers that hopefully have been tuned correctly. But if you change them, you can completely break everything. So you just don't want to touch them. So you actually find one of the controller boards.
But did you write like all software, or there are libraries again?
Yeah, so I wrote the software for that. So my board basically has, I've lost my YouTube channel. Where's it gone?
It
Somewhere.
was on the first one. Yeah, I think
Oh, the
you.
first one I'd
Yeah, but
searched. Let's go back. Um, so I wrote the software, do it. And it's actually, the software is very, very simple because it is just two A to Ds for the left and right directions. So all you're doing is outputting the right numbers to move to the right space. And the actual kind of where's the objects in the game, that's all just kind of
but you
normal
need to
kind of.
create like kind of library with basic commands like draw a point, draw a line or something from this
Yeah, so
point
I
to
did
this
it.
point or something. I don't
Yeah,
know.
it was quite sort of, I did it in a quite an OO object-oriented way. I did use a library for doing all the collision detection. So I
Mm-hmm.
used a library called Box2D, which is actually a physics library for games. It's a C++ library, and you feed in the shapes, and then you can feed in kind of velocities for everything.
Mm-hmm.
And it does all the moving of things and the
Mm-hmm.
animation of things, and all the collision detection. And then you just sit in a loop. You run the physics simulation for a few steps, and then you ask it where everything is and what rotations everything is, and then you can just draw the shapes. And it's kind of is 2D games are fairly straightforward because it's quite high school maths. You're doing kind of 2D rotations and 2D translations, so you are just kind of sines and cos and stuff. It's kind of fun. It's really, I think everyone should try and write a game at some point because it's quite an enjoyable thing to do. I'd written sort of simple games before, so I could use that knowledge on building this. But yeah, it was really nice when it worked. I was kind of like, that's great. Here's one of the on the one video next to it. Oops, that's one of the Galvo boards, and you can see all the potentiometers there,
Mm-hmm.
all the kind of things you could mess up if you start twiddling with your screwdriver on them. It's best not to touch those boards at all. And there's my board at the bottom, so that's my little board, and then I just plugged into the Galvo board. There's quite a few blog posts on the pinouts and stuff, so you're fairly straightforward. Yeah, it
Okay.
was fun.
Okay. I think we are running out of the time. So there is something what I would like to ask. And
Sure.
you already mentioned this, and I mentioned like we would like to maybe talk about this a little bit. And it's I find it when I work on a project, very often happen, almost always, like I have no idea if it's going to work exactly as I
Yeah.
imagine. We already mentioned this. So how do you deal with this? Are there like many projects like you just finish and or you just do the idea proof and you are like, nah, this is not going to work?
I think most of my projects kind of fall into that category.
Oh, really?
Well, I think one of the things I really enjoy is proving that I can do something, and that tends to be proving enough that I know if someone else took something over and they put lots of work into it, they could turn it into something even better. But I've kind of proved that I can solve the problems that I was interested in. So, I mean, things like the DIY Alexa was kind of, well, can I recognize a wake word on an ESP32
Mm-hmm.
using some machine learning? So, oh, yeah, I can do that. It's kind of like, but now I've proved I can do that. That's not so interesting anymore. It's sort of like, now I know I can do it. It's now sort of, well, what's the next interesting problem to solve? So lots of my projects are kind of, can I show that this is possible? Now I've shown it's possible, I'm less excited about it. It's not so interesting now. I don't
I would
want
like
to
to point out actually, there are many times, even for me, I have a couple of projects which are on my shelf, and I started
Mhm.
working with these projects, and I'm like, I'm not going to make video about this because it's not exactly what I imagine. But I
Yeah.
wanted to talk about this topic because maybe some people they are worried, like, okay, I would like to maybe design something, but I don't know if it's going to work. It's
Mm.
completely normal. Like,
Yeah.
I've done some projects, like when I build them completely until like almost last step, like 3D printed the
Uh,
enclosure and put it into enclosure, and I'm like, actually, this looks better than what I imagined. Yeah? But before I was like, I have no idea. Is it going to be ugly, or is it going to
yeah.
be like, is it going to work, or
Yeah. And I think one of the things is it's not really whether or not it works. It's kind of the actual doing of it is the fun bit and the sort of playing around and
but it's better
experimenting.
when it works.
It is better if it works. Yeah. I think that's why sometimes I kind of stop at a certain point because I've reached the point where I know I've done something that's fun, and now it's the really hard bit that might be very difficult and might fail, and it's time to stop before it gets to the horrible bit. I think it's the classic kind of I've done 80% of the project, and now there's just 80% left to do. So, so but I think often the worry that something's not going to work, I think it's sometimes overstated, and often you know quite quickly if something's not going to work because you can do the iterative, can I try it out on a dev board first? Do I do it on breadboard? Play around, try all the different components that I'm trying to use together. Do they all work individually? Can I write the code to talk to them all individually? And then you can start bringing together the bigger project of all the bits you've already kind of prototyped and you know work. So I think
Yeah,
often,
but sometimes, sorry for interrupting. Sometimes, like the toilet project, what I mentioned to you,
yeah,
until I build like complete product,
mhm,
kind of,
yeah,
even inside of enclosure, I had no idea if it's going to work or not.
yeah,
Or I created one of the projects what I'm working on now is keyboard, custom keyboard,
uh,
and
mhm,
okay, I get the PCB, I get the keys and everything, but until you put it inside of enclosure, you
yeah,
still don't see how it is really going to look when it is finished. Like,
no, yeah, yeah, and I think to get over that, I think sometimes you can just say to yourself, well, if it looks terrible, I don't need to show it to anyone. Nobody needs to see this. It's just for me and no one else. But I think often it does come out looking amazing. I think the number of projects that come out looking fantastic compared to the ones that are complete disasters, I think outweighs it and it makes it worthwhile.
and you
And
get
I think,
better. You get better.
you get better, yeah. I think
Yeah.
also definitely get better. I look at PCBs I designed when I was first starting compared to PCBs I do now. And I'm still not an expert at designing PCBs. I've never kind of put myself as a kind of come to me and I'll tell you how to do a PCB. But the difference between what I used to do and what I do now is so dramatic. It's quite crazy.
But
So
many projects what you created, like I think are they look like complicated projects. So I think this can be like very good motivation for everyone who is watching this video and they are still like undecided and they are like, oh, but I never did this, or
Yeah.
I don't know how to start. You started 4 years ago, and
Yeah, I mean,
watch
it's
what kind of projects you.
exactly, yeah. Yeah. I think one of my advantages, I'm quite good at coding, so I can do the software. And lots of modern electronics is mostly software. So you are using an ESP32 where it's kind of, can I program? Yes. Now I can just plug some modules together and get something that is amazing just by using my coding skills to do that. So I think people shouldn't be afraid of the electronics because it is fairly straightforward, I think, to plug things together. And yes, it might not work and it goes wrong sometimes. And yeah, your PCBs come back and nothing works at all and no lights come on. And it's just, what have I done wrong? But it's kind of part of the fun, really. It's enjoyable to solve those problems and work out where you went wrong and go back and do it again and go, oh, I missed a trace or I didn't connect the power. How did that happen?
You will know next time.
Yeah, exactly. You'll know next time to double check. And then you'll still get some mistakes. So
Different one.
different one. Yeah.
Okay, Chris, this was like super cool talking to you, and I hope this video will be inspiration for people who are worried to start working on their own projects, or they can't come up with ideas for their projects. So it means have a look around on internet, find the projects which they find interesting, try to rebuild these projects, and that's how they can start, I think. And then based on what they will learn, they can just grow, they will get more ideas, they will be like, okay, I did this, but what if I do this and I can improve it, maybe I can change this, and I think that's how it starts, correct?
Exactly. Yeah. I think just start building stuff and playing around. And that will take you places and your imagination will sort of pick things up and you'll find new ways of plugging things together. And it's really exciting. I think everyone should have a go at making something and trying something out. It's really fun. I love it.
Before we completely finish, because I try to push a little bit into like 3D printing, because I've seen so many hardware design engineers, they don't want to learn how to do 3D printing and CAD
Yeah.
modeling. What do you think about this topic?
So I think 3D printing used to be really difficult. It used to be very hard to get consistently good results. I remember when I started 3D printing, pretty much every print, I'd have to play around and fiddle with all sorts of knobs on the board to get it level, and then it wouldn't print properly, and you'd be doing glue on your bed to try and get it to stick.
I was there.
Yeah, I think now the printers seem to be a lot more solid and reliable. So you can get prints pretty much every time now. When I use my 3D printer, it will just print without any problems. So I think a lot of the difficulties disappeared now. So I think 3D printing is much more accessible and seems to work a lot better. And there's very cheap printers now, so it's not a massive investment to start playing around with. So I think it's another really fun thing. Sometimes it's annoying because it can fail halfway through, or you can do a 12-hour print that fails part way, and then all you have is spaghetti on your bed. But it's when it works, it is really good fun, and I think.
Do you think it's difficult to learn how to draw mechanical things? And
I don't know. I think most of the things I do tend to be quite simple. So I mean, this one here, it's a box. It's like it's quite easy to draw a box.
You use Fusion, I see.
I use Fusion, yeah, but I've used other CAD tools, and they all kind of will give you the basic shapes. And most of the time, we're printing fairly simple shapes because it is like I need an enclosure for a PCB. So it's like, well, my PCB is rectangular. I'll have a box, and it's quite unusual to try and print complex shapes. So this one here is kind of a complex shape, but it's just two circles. So I think it's easy. It's easy if you're doing fairly simple things. And lots of things you can just download. So the moon lamp I made, I downloaded the 3D model for the moon, so that was fairly easy to print.
Okay. I wanted to mention this because I think it helps to create products. So it's not then only about the boards, but actually everyone who is into trying to design something can create real products. And especially now, because this 3D printing, I always test it at home on my 3D printer, but then I can order 3D printed stuff from like industrial printers. They are like nice. They can do the polish, they can do colors or everything, like, and it's not expensive. It makes the product look much nicer and much better.
Exactly. I really liked my my walkie-talkie case. It didn't take long to design this in Fusion 360, but it made something that would have been a bunch of components into something that felt like a completed real product. Really sort of looks really nice, feels very nice. It is like a walkie-talkie in your hand that you can hold up to your ear. It just makes a big difference to the finished product, I think. It just looks nice, and again, it's not that hard. I think people kind of think it's very difficult because it's like CAD and that sounds difficult, but it's like designing PCBs. Once you start learning the software, you realize it's actually not that complicated really, and it's just learning a few things and watching YouTube videos and tutorials. There's so much helpful stuff that you can watch to learn how to do it. And the 3D printers are now, yeah, as I say, they work. You're not banging your head against the wall trying to get it to print. Works quite well.
I agree. I remember my very first printer, 3D printer, was like very difficult to use, and I stopped using it for like, I don't know, 6 years. I had it in my shelf. I didn't touch it, and then I bought a new one, and it just worked. I was like, it just works.
Yeah, it's sort of almost kind of, when it works and you get one that works really well, you just sort of, yeah, this is how it's supposed to be. This is supposed to work like this. Which is really nice because it's kind of, it's like a magical thing that just produces things out of this spool of filament. Suddenly you have this 3D thing appearing that you've designed and built, and it's great.
Exactly.
It's really nice.
Okay, so is there anything else what you would like to tell people who would like to work on projects, their own projects?
No, I think I'll just repeat what I said before. It is, if you're worried about getting started, then just dive in and start building something. Watch some tutorials and try and recreate the projects and build them. And then it didn't take me long to get to the point where I'm kind of designing things like this, which are really cool and really fun. It's not, and this is actually a very, very simple schematic and PCB. Everything on what looks like quite a complex board are components that you'll see on pretty much every YouTuber's schematic. It's like there's a TP4057 battery charger circuit. You can find schematics for that everywhere. There's an ESP32 S3. It connects directly to a USB socket. There's no complex sort of, you just connect 2 wires and it's talking over USB. There's really not much on what seems like quite a complex sort of board. It's actually really, really simple. So I think everyone should have a go because it's not that difficult, and it is really, really fun.
Okay.
To make and build something. Yeah.
I agree. So thank you very much, Chris, for
Thanks, Robert.
For this talk. I know this was a little bit different video what I normally do, but I still hope, as I said, people find it like an inspiration, and maybe they will be like, okay, I'm going to build this, what I always wanted to build.
Yeah, definitely.
Okay, thank you. Bye, Chris.
Thank you. Bye.
And that's everything. Thank you very much for watching this video. By the way, we are preparing some very interesting tutorials, so if you don't want to miss them, hit the subscribe button. If you want, you can also check out our FedDevel online courses, where you will find everything important from basic board design up to advanced hardware design and PCB layout. The link is in the description. That's all for this video. Thank you again. Don't forget to leave your comments and see you next time. Bye.